In this video, we're going to look at right triangle trigonometry. We want to be able to write right triangle trig ratios, calculate trig ratios using the calculator in the appropriate mode, find missing measures in a triangle, and solve problems using right triangle trig. All right, some review and some new information. Remember, when I have a right triangle, we have one right angle, and then the other two angles can be my reference angle. So here C is my right angle, and then A or B can be my reference angle. In this case, we're using angle A for our reference angle, which means that C is my hypotenuse. A is across from the angle, so we refer to that as our opposite side, and B is touching the angle, so we refer to that as the adjacent side. So what you should remember from geometry is that sine is opposite over hypotenuse, which in this case, referring to this triangle, would be A over C. Cosine is adjacent over hypotenuse, and in this case, referring to this triangle, that's going to be B over C. And then tangent is opposite over adjacent. In reference to this triangle, that's going to be A over B. So you should remember SOHCAHTOA from geometry. There are three more ratios, which we refer to as reciprocal ratios. So if you know sine, cosine, and tangent, if you just learn the definition of the secant, cosecant, and cotangent, then I think that's the easiest way to remember it. So this first one is what we refer to as cosecant. Cosecant is the reciprocal of the sine value, so this is 1 over sine of theta. So I think that's the easiest to remember, is just remember that cosecant is 1 over sine. So the reciprocal of sine would be hypotenuse over opposite, and then again in reference to this triangle, that would be C over A. My second reciprocal function is abbreviated SEC. This is referred to as secant. Secant is the reciprocal of cosine. So secant's 1 over cosine. So in terms of opposite adjacent hypotenuse, that's going to be hypotenuse over adjacent. And in terms of this triangle, that's going to be C over B. So if it helps you to remember it, I remember that they're opposite letters. Cosecant starts with C. It's the reciprocal of sine, which starts with S. Secant, which starts with S, is the reciprocal of cosine, which starts with C. The last one is abbreviated COT, and this is cotangent. Cotangent's the reciprocal of tangent. So that one's easy to remember because it has the word in it. So in terms of opposite adjacent hypotenuse, this is going to be adjacent over opposite. And in terms of this triangle, that would be B over A. So you need to remember your SOHCAHTOA from geometry, and then if you can just remember your reciprocal definitions, cosecant's the reciprocal of sine, secant's the reciprocal of cosine, and cotangent's the reciprocal of tangent. So if we look at an example here, we want to find the exact value of all 6 trig ratios. So when it says all 6 trig ratios, it means we want you to write sine, cosine, tangent, secant, cosecant, cotangent of the reference angle. So in this case, we're using theta for our reference angle. So this is my reference angle. So the first thing you want to do is figure out which your opposite adjacent hypotenuse. So I know this is hypotenuse because it's across from the right angle. 9 is opposite because it's across from the angle. And then this side is touching the angle, so that's my adjacent side. And so the first thing that you notice is that the adjacent side we don't know, so we need to figure that out. So we have to remember the Pythagorean theorem, which says a squared plus b squared equals c squared. So I'm just going to use the values that I have here. So I get a squared plus 9 squared equals 13 squared. So using the Pythagorean theorem, we end up with a is the plus or minus the square root of radical 88. We're going to choose the positive because it's the length of a side of a triangle, so we know that it's going to be positive. And then we're going to simplify that radical, and we get 2 square root 22. Once I have all 3 sides, then I can start writing out my ratios. It does not matter what order you write them in, so I'm just going to go the sine of theta. Remember, sine is opposite over hypotenuse, so my opposite side is 9 over 13. Reduce if possible. In this case, we can't. So then we're going to do cosine of theta. So cosine is adjacent over hypotenuse, so 2 radical 22 over 13. Again, reduce if possible. 2 and 13 don't reduce, so we don't have to do anything there. Tangent of theta, remember tangent is opposite over adjacent, so in this case we're going to have 9 over adjacent, which is 2 radical 22. Remember in Algebra 2 you learned about not leaving radicals in the denominator. It's not necessarily always the case for us. Sometimes you will be asked to rationalize, sometimes you will not. Basic rule of thumb is unless the directions tell you that you have to rationalize, you do not have to rationalize. So it's okay to leave the radical in the denominator unless you're specifically told to rationalize. Just a quick review, if you are asked to rationalize, if we have a radical in the denominator, we're going to multiply the numerator and the denominator by that value. So in this case, we're going to get 9 radical 22 over 2, and then radical 22 times radical 22 is going to give me 22. So we're going to get 9 radical 22 over 44. Again, simplify if possible, but we can't, so we're just going to leave it at that. Once I have sine, cosine, and tangent, which I'm going to remember from geometry using SOHCAHTOA, then we can do the reciprocal functions. So remember, cosecant is the reciprocal of sine, so I'm just going to go to my sine value and I'm going to flip it, so 13 over 9. Secant is my reciprocal of cosine. Secant is my reciprocal of cosine, so I'm going to flip that one. So we have 13 over 2 radical 22. Again, let's just practice rationalizing this one. So we're going to multiply by radical 22 over radical 22. And we'll get 13 radical 22 over 44. And then finally, we want to do cotangent. Cotangent is the reciprocal of tangent. If I come and I take the reciprocal of this answer here, we're going to end up with a radical in the denominator. We're going to have to rationalize. So if you have a value that was rationalized, just come back and use this first answer that we had before we rationalize and flip that, and then your radical will be in the numerator and you won't have to worry about anything. So this will give me 2 radical 22 over 9. All right, similar question. It's just kind of presented a little bit differently here. It says assume that theta is in an acute right triangle. Evaluate the other 5 ratios given that cosecant of theta is 12 over 5. So first of all, as soon as you have one ratio, you always know the reciprocal one. So if we think right away, cosecant is the reciprocal of sine. So the first thing I know is that the sine of theta is the reciprocal of this, which is 5 over 12. So draw yourself a right triangle, make one of the acute angles theta. It does not matter which one you make theta. All that matters is that the relationships are appropriate. So we just want to pay attention to where we put things once we have theta in there. So remember, sine of theta is opposite over hypotenuse. So opposite from theta, I'm going to put the 5 on the hypotenuse, which is across from the right angle. I'm going to put the 12. And then again, we're going to use the Pythagorean theorem to find that missing side. So we have x squared plus 5 squared equals 12 squared. So here we end up with x is plus or minus the square root of 119. Again, we're going to choose the positive because it's the side of a triangle, so I know it's positive. Radical 119 does not simplify, so we're just going to leave it in that radical form. So again, once I have all 3 sides, I can come up with my other values. We already found sine, so now we're going to do cosine. Cosine is adjacent over hypotenuse, so we're going to have radical 119 over the hypotenuse, which is 12. We're going to do the tangent of theta, which is opposite over adjacent. So opposite is 5 over the adjacent side, which is the square root of 119. And then we can do the reciprocal of cosine, which is secant. So 12 over square root 119, we're just going to leave the radicals in the denominator here. And then we get the cotangent of theta is the square root of 119 over 5. So these problems always involve finding the missing side if you're only given 2 sides, and in order to do that, you're going to use the Pythagorean theorem. Okay, so we want to remember when we're using our calculator to find sine, cosines, and tangents, we have to pay attention to the mode. So we have to look at our angle and see what unit it's in. Is it in degrees or radians? And then we have to make sure that our calculator is in the appropriate mode. If I'm just doing a simple like cosine of 36 degrees, I would want to make sure I'm in degree mode and then just type cosine 36. Don't put the degree symbol in there. Just make sure that you're in degree mode. Only use the degree symbol if you're also going to continue with a minute or a second symbol. If you're going to do secant, cosecant, or cotangent, you have to use your reciprocal definition. So again, it's important to remember those definitions that we talked about earlier. And then when you are trying to find an angle measure, so when we have the sine of x equals 0.5, in order to get this x by itself, we would have to bring the sine to the other side, in which case it has to be inverse. So this is inverse sine of 0.5. This one asks for it x to be in degrees, so we would change the mode and make sure we're in degree mode, and then we would use that inverse sine. So just a couple here that we can practice with. So the first one is tangent of 8 degrees, so make sure your calculator is in degree mode, and then you're just going to type tangent of 8, and let's round to 3 decimal places, it says, so we get 0.141. Remember, for this second one, we have degrees and minutes. So first, make sure we're in degree mode. So I'm in degree mode over here, and then I'm going to type cosine, and then we can do this 2 different ways. 23, and then I'm going to get the degree symbol, and then 42, and I'm going to get the minute symbol, and I can do it that way. Also, you can just do the conversion right in the parentheses. So you can do a cosine of 23 plus 42 divided by 60. So remember, my conversion from minutes to degree is divided by 60. And you can see we get exactly the same answer. On C, we have cosecant, so we have to do it as its reciprocal definition. So 1 over the sine of pi over 10, which gives us 3.236. Remember, make sure you're in radian mode for that one. This next one is secant. So remember, this is 1 over cosine of 1.24. This is a radian measure. There's no degree symbol, so you should still be in radian mode. And we end up with about 3.079. The next one's fairly straightforward, sine of pi over 15, so radian mode, and we should get about 0.208. And then the last one on this side is cotangent of 19 degrees, so we want to change back to degree mode, and then this is going to be 1 over tangent of 19 degrees. Remember, you don't need the degree symbol here because there's no minutes or seconds. And we get about 2.904. Okay, over here on the other side, we're using inverse, and then the answer, or the mode that would be in the direction. So I just put those in parentheses afterwards. So this first one, we're going to make sure that we're in degree mode. Remember, to do the inverse, you're going to do secant sine, and then your argument 0.75. And here we get about 48.590. I'm going to skip down to I so I can stay in degree mode, and here we have inverse cosine of 0.75, so again, fairly straightforward, and we get 41.410 if we round. And then this last one, we have inverse sine of 1.3. Notice here you get an error. It says domain error. The argument here has to be between -1 and +1. So if you go outside that range, you're going to get this error message, which is fine. And then you can just say this is no solution. All right, so these other two, we need to be in radian mode. So make sure you've changed back to radian mode. And then on H, we're just going to do inverse tan of 1.5. And we get 0.983. And on J, when we do inverse sine of -0.25, we get -0.253.